Hi, I'm Brad Brim of Cadence Design Systems. Welcome to Sigrity Tech Tips. Today, we bring you yet another installment of how to build and verify your multi-gigabit serial link to meet industry compliance standards. Our video today will show you how to perform full-wave 3D accurate extractions 10 times faster than using a traditional full-wave 3D extraction approach. Using a cut-and-stitch methodology, Sigrity offers you the right field solver for the right section of the serial link channel. This is an important step in achieving multi-gigabit serial link compliance. You will use full-wave 3D where you truly need it and our fast hybrid solver technology where you do not. The significant time reduction will allow you to detect problems, make changes to your design, and meet industry compliance standards the first time, and on budget. In today's video, you will see us utilize the Allegro Sigrity SI base and the System Serial Link Analysis option. To learn more about these products, visit us at www.cadence.com. Please allow me to now turn it over to my colleague, Charlie Shi.
In many cases, PowerSci can provide a very good accuracy model compared with 3DM. In this demo case, we see there is a need to switch from PowerSci to 3DM for higher accuracy model due to 3D structure, especially at higher frequency area. Let's look at the performance of 3DM versus PowerSci hybrid solver. In this demo case, PowerSci only takes 5 minutes and 20 seconds, but 3DM takes 9 hours and 20 minutes to get a differential pair as parameter. Normally, full-wave 3DM is accurate but takes long. On the other hand, PowerSci hybrid is faster, but it could slightly lose accuracy at higher frequency, say 15 GHz in this demo case. So to balance the accuracy and performance, we have introduced a cut-and-stitch flow in 3DM. It can provide a complete and automatic way to divide long traces into partitions, automatically generate ports at boundary. It allows you to select solver at any partition and run simulation, and finally cascade the S parameter coming from each partition automatically. Here is the correlation data of 3DM cut-and-stitch compared with 3D full structure. In the cut-and-stitch simulation, there are 7 partitions are cut and run simulation with 3D EM full-wave solver. On the full frequency range, both the results are matching very well. The simulation time of cut-and-stitch is only half of full structure. To reduce the simulation time in advance in cut-and-stitch flow, we have tried to reduce the partition number and mix 3DM and hybrid solver together. We only use 3DM solver at both terminal end, and the middle portion is resolved by hybrid solver. The new results still correlate very well between cut-and-stitch and full structure, but the simulation time of cut-and-stitch flow is dramatically reduced to 15 minutes only. In next demo section, we will show how easy to switch from PowerSci to 3DM. Here is the 3D FEM full-wave extraction environment. We select a PCI Express differential pair. There is a via transition from top to bottom layers. First of all, we would like to show you how to reduce the design into a small portion. In 3D-EM, there is an automatic way to handle this. Based on the length you selected and the margin you set up, the tool will automatically create a boundary and cut out the other portion. Now you can save the differential pair area into a new SPD file. The next step, we would like to divide this differential pair into several partitions. Here we again select the editor cutting boundary function and draw any cutting line at the place there you want to divide a partition. For this differential pair, we divide it into 5 partitions. Next step, we need to generate ports at both ends. In 3DM, there is a port wizard to automatically create ports based on the components you selected. Now, there are 4 ports are created. At the left side, there are 2 ports, and the other 2 ports at the right side. Simulation setup. First thing, you will change the frequency to 20 GHz and leave the solver option as default. Here you can control the solution accuracy. We use the conformal outer box boundary. Cut and stitch option setup. In 3DM cut and stitch flow, at the boundary we automatically create ports. Now you can import the 5 partitions we just created in previous step. Here you can assign either full-wave 3D EM solver or hybrid solver on each partition and generate SPD file for each partition. Now the SPD file for each partition is created. You can go to check the SPD file. They are stored in each folder for each partition. Now it's ready to run the simulation by cut and stitch. For each partition, they will be simulated one by one in one machine, or you can distribute them into several machines to speed up the simulation. Now we open up the finished result we have simulated to show you the final result for this case. When the simulation result is completed, the result will be updated. Now you can load the final result and check the S-parameter file. This final result is basically automatically cascaded from each partition. In summary, when design is getting complicated with more 3D structure, 3D EM full-wave solver becomes a must to provide accurate sign of results. In the same GUI, as you can see from the video, switching from power side to 3DM is seamless with smart utility in 3DM. Cut and stitch flow in 3DM can also provide an diffusion methodology to get full wave accuracy model in 10 times faster than full 3D single structure extraction.
Thank you for watching another edition of Sigrity Tech Tips. For information on the products used in today's video, click on the links below or contact your local Cadence sales representative or Cadence channel partner.